If you've been writing software for more than 2 years, you already know git stash, cherry pick, rebase, bisect, the usual suspects. This video is not that. In the next 7 minutes, I'm giving you 5 advanced Git workflows that almost no developer uses, and every senior engineer leans on every single week. These aren't tricks. They're the workflows that make you the person on your team who actually understands version control. Save this. You'll come back to it. Each of these solves a real problem at scale, the kind of problem you only hit when your repo gets big, your team gets big, or your history gets messy. 5 deep dives, no filler, no commands you already know. Let's go. Number 1, rebase dash dash onto. Every Git tutorial teaches you Git rebase main. But what almost nobody teaches you is rebase dash dash onto, and it's the most powerful branch surgery tool Git has. Imagine you branched off feature A, did 3 commits on top, and only later realized you should have branched off main. Plain rebase will pull in all of feature A's history. You don't want that. The command you want is git rebase dash dash onto main feature dash ahead. In English, that means take every commit from feature A up to my current head and replay them on top of main as if I had branched correctly from the start. 3 messy commits move cleanly to a new base, and feature A is no longer in your history. This is how senior devs untangle branch mistakes that would force a junior to start over from scratch. Number 2, partial clone with sparse checkout. The problem: you join a company with a 5 GB monorepo, and a fresh clone takes 30 minutes. You only need to work on 1 folder. Why are you downloading everything? Modern Git has 2 features almost nobody uses together. Partial clone lets you fetch only the commit history without the file blobs, using get clone. Dash dash filter equals blob :none. Sparse checkout then tells Git which subset of the working directory to actually materialize on disk. Combine them with git sparse dash checkout init dash dash cone, then get sparse dash checkout set with the directory you care about. The result: you clone in seconds, your working directory only contains the folders you need, and Git lazily fetches blobs only when you actually touch a file. This is how engineers at Google and Meta work in repos with millions of files. The tooling is in your Git client right now. You just need to know it exists. Number 3, rerere, reuse recorded resolution. The problem: you're on a long-lived feature branch, and every time you rebase onto main, you hit the same conflicts in the same files, and you resolve them the same way. It's pure tax on your time. Rerere fixes this. Turn it on once with git config dash dash global rerere dot enabled true. From that moment on, every time you resolve a merge conflict, Git records the conflict signature and your resolution. The next time the exact same conflict appears on a future rebase, on a teammate's machine if you share the rerere cache, Git auto-applies the saved resolution. Same conflict, same fix, automatically. On a 6-month feature branch, this saves hours per week. It's been in Git since 2008, and it's still the most underused feature in the entire tool. Number 4, custom merge drivers. The problem: package-lock.json, yarn.lock, and any auto-generated file are merge conflict nightmares. 2 devs add dependencies. You both regenerate the lock file, and now you have a 6,000-line conflict that no human should ever resolve by hand. The senior solution is a custom merge driver. In your repo's .git attributes, add a line: package-lock.json merge equals npm-lock. Then in your .git/config, define merge.npm-lock.driver as a script that runs npm install and overwrites the lock file from scratch. Now every merged conflict on the lock file auto-resolves by simply regenerating it from the merge package.json. You can write merge drivers for any generated file: Prisma migrations, generated GraphQL schemas, compiled CSS. The principle is the same. Don't merge generated files, regenerate them. Number 5, shared Git hooks the right way. The problem, every developer on your team is supposed to run a pre-commit hook that lints, formats, and runs type checks. But hooks live in .git/hooks, which is per clone and not committed. People forget. Standards drift. Bad code lands. The proper fix is twofold. First, commit your hooks into a folder in your repo, for example, .git hooks. Second, configure Git to look there with git config core.hooks path.git hooks. Ideally inside your project's setup script so every fresh clone runs at once. Now every commit on every machine runs the same checks. For more power, layer Husky or left hook on top. They handle the install step automatically and let hooks be configured in package.json. The point isn't the tool. It's that hooks become a versioned, shared part of your codebase, not a per-developer afterthought. This is the difference between a team that ships clean code and a team that argues about formatting in code review. 5 workflows. Each one solves a problem most developers don't even know is solvable. The gap between a senior engineer and everyone else is rarely about syntax or frameworks. It's about knowing the right tool exists and reaching for it instinctively when the situation calls for it. Drop these into your daily workflow and watch how many problems just stop happening. If this leveled you up, follow for more dev workflows that actually move the needle. Drop a comment with the word Git if you want a part 2, submodules done right, the maintainer's guide to bisect, and the Git internals every senior eventually learns. See you in the next one.